Solve the inequality x to the fourth minus 6x cubed plus 8x squared is greater than or equal to 0. Graph the solution set and express it in interval notation. This one is more complicated because it is a fourth degree polynomial. However, we have the tools to solve it, and I want to go through this so you can see how a slightly more complicated example will work. We're still going to start by solving the corresponding equation. So we have x to the fourth minus 6x cubed plus 8x squared is greater than or equal to 0. Factoring this requires pulling out a GCF first. We can pull out an x squared, leaving us with x squared minus 6x plus 8. And then for the leftovers in the parentheses, we can use the unfoiling method. We need two numbers that have a product of 8 and a sum of -6. Those are going to be -4 and -2. Now we set each factor equal to 0. X squared equals 0, x minus 4 equals 0, or x minus 2 equals 0. And solving each of these, the first one, x squared equals 0, only has one solution, x equals 0. The next one has x equals 4 as a solution, and the last one has x equals 2 as a solution. So we can make our number line, and we know that it needs to include the numbers 0, 2, and 4. All right. Those are going to be our critical numbers, 0, 2, and 4. And because this is greater than or equal to, we're going to use closed circles on each of these. All right. Now we need to put each of the factors on the left-hand side. We've got x squared, we've got x minus 4, and x minus 2. X squared is always positive, except of course when it's 0. But we don't care, we're just looking at these other intervals. It's never negative, so we're going to have positive for all of those. X minus 4 is going to be positive so long as x is greater than 4, and negative in all the other situations. And x minus 2 is going to be positive so long as x is greater than 2, and negative in the other situations. So then in the end, our whole expression is going to be, let's see, a positive times a negative is going to be positive. The same is going to be the case here. It'll be positive. Then over here, it'll be negative. And then in the last interval, it's going to be positive. So remember, we wanted our expression to be greater than or equal to 0. So we need to shade in the intervals where it is greater than or equal to 0, so where it's positive, so that's going to include this first interval. It's going to include the second interval, and it will include the last interval. So we have, for our solution, from -infinity all the way up to 2, and then union the interval from 4 to infinity, and that is where our expression is going to end up being greater than or equal to 0. Now, I do want to explain one more little thing here. This is just tangential. We recall from an earlier video that there's a relationship between this number line and then also the graph of y equals x to the fourth minus 6x cubed plus 8x squared. Because we wanted to see where this is greater than or equal to 0, these intervals correspond to where the graph is above the x-axis, because those are positive values of y. If we were to sketch a quick graph of the polynomial y equals x to the fourth minus 6x cubed plus 8x squared, we know that that is going to be equal to 0 at these 3 points, because these were the critical numbers. And we know that it's going to be above 0 on these intervals. If you were to go through and actually graph this, you would get something that looks something like this. It's not a perfect graph, it's just a very, very rough sketch. But this is what's going on here. On the intervals where we have solutions, this is where it's either above or on the x-axis. And then where we don't have a solution, that's where it dips down below. This is a fourth degree polynomial equation. It's not going to be a parabola. Parabolas were only when we had second degrees. When the degree is higher, you end up with more wiggling, usually. And we are going to look at graphs of polynomials like this later on in the semester. So this is not something that we need to be able to do now, but I wanted to look at it because it does give us a preview of something we'll see later, and it does draw a connection between a two-dimensional graph and then this one-dimensional inequality.